In this video, we'll be solving this chemistry problem relating to acids and bases and the concentrations of hydroxide and hydronium. So, here is the problem which asks us to actually prove or demonstrate something based on some conditions. Here's the statement. Show that the hydroxide ion concentration in aqueous solution is 1 times 10 to the negative 4 moles, or moles per liter, when the hydronium ion concentration is 1 times 10 to the negative 10 moles. So, they just want to demonstrate that this is actually true using, there are some rules about what happens with these exponents. So, to solve this problem, we have to utilize the fact that when we have the same base, the base is this lower part, like the 10 here, that's shared. When we have the same base, then if you're multiplying those exponents, then all you have to do is add the powers. So if you're doing 10 to the negative 4 times 10 to the negative 10, then you're just adding the power. So negative 4 plus negative 10 is going to be your exponent. Negative 4 plus negative 10, and that's going to be negative 14. So all of that just equals out to be 10 to the negative 14. So that's the rule for multiplying exponents there. So given that, we can now see how this is the case. So as a brief review, the hydroxide ion concentration in any solution always represents the base part of the solution. Hydroxide is the result of the base component, and the hydronium is the result of the acid component. It's what causes the acidic pH. So, when it comes to balancing these concentrations, they always have to equal the Kw constant. And in chemistry, what this means is the constant amount, total concentration of hydroxide and hydronium ion concentrations. So, and the Kw, all we need to know about this is that this constant is negative 14, but then you always take the negative logarithm or just the negative exponent of the total concentration, so it really is 14 in the actual value. So, given that this constant is 14, we know that the pHs, basically, or the concentrations of the hydroxide and the hydronium must add to 14. So, we know that since we can just we can just add the powers when we're multiplying, we can do, if we know the hydronium concentration is 1 times 10 to the negative 10, negative 10 minus negative 10 plus negative 4 is going to be negative 14. Then we always take the negative logarithm, so negative 14, invert that, and you got 14, which is the Kw constant. So we know, we've demonstrated, that we must have the hydroxide ion concentration of 10 to the negative 4 moles when we have the hydronium concentration of 1 times 10 to the negative 10, because we have here, this equation is what gives rise to that.